All right, we're going to take a look at writing and analyzing linear equations for real-world situations. So we have a table of data, and we have a bird, well, the bird's egg, the length of the egg versus the mass of the egg. So what I've done is I've graphed this information. The length I'm using as my x value. The mass is the y value. And so I have labeled that information down here on my graph. The length is along the x-axis. The mass is along the y-axis. I have chosen a scale that spreads my data out along the graph. I noticed the length only goes from about 1.9 up to just over 6. So I chose to go by 1 but skip a line every time. And I looked through the mass, and my highest one was 63.8. So I went by 10s, also skipping a line every time. So when I have the data drawn, it looks something like this. It's not a perfect line. We do not want to play connect the dots. What we're going to do is we're going to draw a line of best fit. Now, if you have a clear ruler, that is the best way to do this. I don't know where my clear ruler is right now, so I'm going to use this wood ruler. So what I'm going to do is I'm going to try to go through as many points as possible. It's not going to be perfect, and it's very hard to see because I don't have, so it looks like I have a nice cluster right there. And your line is going to be a little different from mine, but I'm just going to go for it here. Drawing my line up. Remember, this will extend. Yeah, it's not the best. What I really should be looking for is the same number of points on each side. So I could have adjusted it, but I'm just going to keep it like that. A better line would maybe go through more of these points. But this is just a model, and everybody's going to be slightly different. So if you didn't have the best line of best fit, that's okay. All right. So I did extend my line down so that I could kind of see where it might cross the y-axis. It's hard to tell. Okay. So now that I have my line, it says extend your line to the y-axis. What is the y-intercept of your line? Well, it's kind of hard to see here, but I'm just going to estimate it. This would be -10. This would be -20. I think it's about -30. Again, because my line's not perfect, your answer might be different from mine. So my y-intercept is going to be -30, and then explain the real-world meaning of your y-intercept. So that means that when the length of the egg is 0, the mass would be -30. Okay, so when the length of an egg is 0, the mass would be -30. So this kind of doesn't make sense that we would have a negative amount of weight. And you would think that when the length of an egg is 0, the mass would also be 0. So it's kind of interesting. Sometimes when we do these lines of best fit, we do need to make note, like in this context, this answer would not make sense. But we can still write what it means. Okay, now the next part. This is to choose 2 points that are on your line of best fit. So I got to go back to my graph here, and I'm going to choose 2 points on my line of best fit, and I'm going to use a different color. Oh, I've got a nice pink pen here. Hang on. All right. So I'm looking for some, ooh, I like this point here. It goes right through my line. It's a nice cross section. I'm looking for points that are going to be easy to calculate. Oh, here's another really nice one. So they don't even have to be points that were in the data. They can just be points on this line. So according to what I found, I have a point at 3.5, 20. So point 1 is going to be 3.5, 20. And point 2 is 770. Okay. Use the slope formula to calculate the slope with the 2 points you picked. So slope formula is y2 minus y1 over x2 minus x1. And all these sub numbers mean is that whatever y value you start with first, you're also going to start with that x value. So going back here, if I start with the 70 as my y value, so I'd have 70 minus 20, so this y value minus this y value, over, I got to go back here and start with this x value, 7 minus 3.5. So I know 70 minus 20 is 50. 7 minus 3.5. Wow, these are such nice numbers today. It's 3.5. And then I'm going to divide that out. So 50 divided by 3.5. And that's going to be a decimal, so I'm going to round it. It's 14 point, we'll say 3. That's my slope, 14.3. And then it says, explain the real world meaning of your slope. So what does this mean? We need some type of a label. So if we go back and think of slope, slope is the change in y over the change in x. So I'm going to go back and look, what is my y value? My y value is grams. So I'm going to put grams per. My x value is centimeters. So the label of my slope really should be grams per centimeter. So the meaning of my slope is that an egg, or for, let's see, for each 14.3 grams, the egg will be 1 centimeter long. For each 14.3 grams, an egg will increase by 1 centimeter. Now, this is not perfect. This is just a model. Remember, if we look at our data, the eggs are not all on my line. So it doesn't mean that every egg is perfectly following this rule. But in general, we can make an estimate that every time an egg goes up 14.3 grams, it will increase by 1 centimeter. So I did that by looking at my labels for the x and the y. Well, y first over x. Okay, using your slope and y-intercept, write an equation that models the data. So remember the format for an equation. Y equals mx plus b. M is the slope. B is the y-intercept. We've identified each of those pieces, so this equation is really simple. Y equals slope, I said was 14.3, x minus, remember I had that funny y-intercept, minus 30. Doesn't seem like it should be that much, but that's what my line gave me. Remember, my line's not perfect. If I had a clear ruler, I would have drawn a better line. If a mallard duck egg is 4.4 centimeters long, use your equation to predict the egg's mass. So here's my equation here. We need to remember that x is the length, and that's in centimeters, and y is the mass, and that's in grams. So I'm using my formula, y equals 14.3x minus 30. 4.4 centimeters is a length. So I'm going to replace the x with 4.4 centimeters. So I have y equals 14.3 times, because 14.3x means times x, 4.4 minus 30. Now I just have a problem to solve here. Very simple. 14.3 times 4.4 gives me 62.92. 62.92. And we have to subtract 30 as well. So y equals 32.92. Remember, the y is the mass, so I need to put grams. So if somebody said, how much would a 4.4 centimeter long egg weigh, I could say 32.92. Now let's go back to the graph. 4.4 is right about here, going up. You can see that I crossed my line just above the 30. So 32.92 makes sense. Use your equation to predict the length of an egg that weighs 25 grams. So again, I'm using that equation I wrote. Y equals 14.3x minus 30. And this time I have grams, given 25 grams. Going back, y is the grams, it's the mass. So I'm going to replace 25 for y. So 25 equals 14.3x minus 30. I need to know what x is. I need to solve this equation. So I got to get x by itself. So I'm going to add 30. I get 55 equals 14.3x. So 14.3x, or 14.3 times x. So we need to divide by 14.3. If I do it to one side, do it to the other. X is left by itself. It's 55 divided by 14.3. And again, it's a decimal. I'm going to round it. It's going to be approximately 3.8. And this is the length. So I need to say that this is 3.8 centimeters. So again, I can kind of look at my graph. An egg that weighs 25 grams. So 25 is right about here. Going across, I see that, oh, I'm almost to 4. So, I'm 25. Yeah, 25. 25 is right here. 3.8. It's just about 3.8. So you can see that would fall on my line. So when you do this, you will have a different line. So you will have a different slope. You will have a different y-intercept. That means your answers here will be slightly different. I'm looking to see that you've done the correct work and that your answers are in the ballpark of mine. Okay, so hopefully this helps. You're gonna complete the other problems just like this.